In today's video, we are going to be answering GCE 2020 question 4. Question 4 someone reads, the function f of x is equal to x plus 1 divided by x minus 1, bracket close, in bracket open, x squared plus 1, bracket close. Express f of x in partial fractions, hence find the integral of f of x dx. Question 4 sub 2. By using the substitution u equal to sine x, find the integral of cos x divided by 1 plus sine squared x dx. Question 4 sub 3. Find the integral of x plus 2 times e to the 3x dx. So, now let's begin. The first part says that we should express f of x in partial fraction. So, we know that our f of x is equal to, now to express this in partial fraction, we know there are rules guiding functions. Either it's a linear function, it's a quadratic function, it's a cubic function. So for each of those functions, there is a particular way in which we need to express them in terms of a, b, and c. So we know that for linear function, we are simply going to express this as a all over x minus 1. Now this is a quadratic function. So for quadratic function, they are expressed in the reduced partial fraction in the form bx plus c, now divided by the quadratic function. So I'm going to make a special video for partial fractions that will be able to take care of all the cases, so that whenever any question comes under partial fraction, you'll be able to handle it. So now if we solve this, or if we simplify this, we're going to have the LCM will just be the product of their denominator. So here will be x minus 1 and x squared plus 1. So now looking at this, we need to further simplify it. So we take all of this divided by this, and if we do that, we are going to be left with x squared plus 1. Now x squared plus 1 times a is simply going to give us a into x squared plus 1. Now the same thing is going to be done with the second term. So we take all of this, we take all of that and we divide by this, and if we do that, we are going to be left with x minus 1. So plus bx plus c into x minus 1. So what are we going to do now? If you look at it critically, if we compare it with the function f of x, we are going to see that the denominator, in this case we are dealing with the denominators here and this denominator, they are equal, and by equating them, therefore what are we going to say? If the denominators are equal, therefore the numerators should be equal for us to further simplify it. So the next thing we need to write is therefore this implies that x plus 1 is the same as a into x squared plus 1 plus bx plus c into x minus 1. Now looking at this, we can look for the value of a, b, and c by simply letting x to be equal to some certain values that will enable us to calculate the values of a, b, and c. So the first thing we're going to let is when x is equal to 1, therefore we're going to have 2. We're going to have 1 plus 1 to be equal to a into 1 squared plus 1. Now if we put 1 here, we're going to have 1 minus 1. So this is going to give us 0. It's going to give us 0, and we know 0 times anything, if we are multiplying 0 times anything, is going to give us 0. Therefore this term will give us 0. So plus 0 will simply be 0. Now if we continue, we're going to get 2 here to be equal to 2a. So what does this imply? It implies that a is equal to 1. So this is our value of a. Now which value of x are we going to put such that we're going to get the other constant? So now let's let this time around x to be equal to 0. If x is equal to 0, therefore putting 0 here, we are going to get 0 plus 1, which will give us 1, to be equal to, putting 0 here, 0 plus 1 is going to give us, putting 0 here, 0 plus 1 is going to give us 1. 1 times a is going to give us a. Now plus, putting 0 here, we are going to get 0 plus c is going to give us c. And now putting 0 here, we are going to get 0 minus 1, which will be minus 1. So we have 1 equal to a minus c. But what do we know? We know that we know that from here a is 1, so we simply substitute there. So we're going to get our c. Let me make our c subject of formula. So we know that c will be equal to a minus 1. So this simply implies that c will be equal to 1 minus 1. Therefore our c is 0. This implies that c will be 0. Now that is our value for c. Now to get the value for b, we let x to be equal to another number. Let's say x should be equal to negative 1 this time around. Now notice that whenever you let x to be some certain values, do not repeat those values, because if you repeat them, you're simply going back to what you have done already. So always try to look for different values for x so that you can get different equations. So if we let x to be equal to minus 1, therefore we're going to get we substitute it in our initial equation. We're simply going to get minus 1 here, minus 1 here, plus 1 is going to give us 0, to be equal to, if we put minus 1 squared, is going to give us 1, plus 1 is going to give us 2. So we are going to get 2a here. Now minus 1 here plus minus 1 here is going to give us minus b. Now plus c, we can simply write it as c minus b, and now minus 1 is going to give us minus 2. So the space is kind of small there, so I'll have to manage it. So I'm looking for b. I need to make b subject of formula. So if I send a this way, I'm going to get minus 2a to be equal to minus 2 into c minus b. So we know our value for a and our value for c. We simply substitute it here. So our a is 1, means that here we are going to have minus 2 times 1 is going to give us minus 2, equal to minus 2 in bracket. What is our c? Our c here is 0, so we're simply going to have minus b here. Now expanding it, we're going to have minus 2 to be equal to minus times minus is going to give us positive, so 2b. So finally our b will be equal to minus 1. So now we have our value for a, b and c. So what we need to do is simply substitute in our function here, in our f of x. That will be our partial fraction. So we know that f of x will be equal to x a divided by x minus 1. Our a was 1, so it will simply be 1 divided by x minus 1 plus bx. Our b was minus 1, so it will be bx, so it will be minus x plus 0 divided by x squared plus 1. So this will further simplify to 1 divided by x minus 1 minus x divided by x squared plus 1. So now, one thing I like about a partial fraction is that you can always verify if your partial fraction is correct or not. Now, to do this, we simply go back to the function that the equation gave us. We know that f of x was x plus 1 divided by x minus 1 and x squared plus 1. So now, if we let our x to be a value like let x to be equal to something like 2. Now I will not take 1 because when x is 1, this function f of x will not exist. So always make sure to check. So if x is 2, we are going to get 2 plus 1 is going to give us 3 here, and 2 here is going to give us 1. So 2 squared will give us 4 plus 1 5. So our partial fraction says that, our original partial fraction says that when x is 2, therefore f of x will be 3 on 5. So what we need to do is just to verify if our own partial fraction that will reduce will give us 3 on 5 when x is 2. Remember, this is for you to check if your answer is correct or wrong, and this is done on a rough work, not on your answering sheet. So in our partial fraction, this is our partial fraction, we need to substitute the value of x equal to 2. Notice that when you test in the original function letting x to be 2, you also use the same value to test in your partial fraction. So now when x is 2 here, we're simply going to have 1 divided by 1 minus 2 divided by 5. So our LCM here is 5. So 5 divided by 1 is going to give us 5. 5 times 1 is going to give us 5. Minus 5 divided by 5 is going to give us 1. 1 times 2 is going to give us 2. So this will be 3 on 5. So here you are already satisfied that your partial fraction is correct, since it is the same as this. So that is the answer for means that this our partial fraction is a solution, is a partial fraction for f of x. Question 4 sub 1 says that after expressing this in partial fraction, hence find the integral of f of x. Now before I continue, I would like to mention something. Whenever an equation says that hence find something, it means that you need to use your answer to get the next answer, because if the question says that hence or otherwise, you can use a different method. This is a trap in which thousands of students falls into. But once ever any exam says that hence, it means you need to continue from where you stop in order to get the next answer. Now, to look for the integral of f of x dx, this will simply be equal to the integral of our function 1 divided by x minus 1 minus x minus x divided by x squared plus 1 dx. So this will be dx. So we can further simplify this. This is the same as the integral of 1 divided by x minus 1 minus dx. But differentiated with respect to x minus the integral of x divided by x squared plus 1 dx. So the integral of so we are going to break it down. The first one is the integral of 1 divided by x plus minus 1 dx. Now to integrate this, we see that differentiating the denominator, that is, if we differentiate x minus 1, we are going to get 1. Therefore, the differential of the denominator is equal to the numerator. Our result will be equal to ln. So here the answer will simply be the ln of the absolute value of x minus 1 plus c. let me just say c1 plus a constant c1. For the second integral, which is this, we are going to have the integral of x divided by x squared plus 1 dx. So what do we notice here? When we differentiate the denominator, we are going to have 2x, so it is not exactly equal to the numerator, so we need to create and destroy two in order for them to be equal. I'm going to make a different video on integral, so you'll be able to understand what I'm saying. We have if I put 2 here and a half here, I haven't changed anything in this equation, because differentiating this, I'm going to get 2x, so it will be equal to this. So this will simply be the ln of the absolute value, or half. This will simply be half the ln of the absolute value of the denominator, now plus c2. So I have to combine now our answers. Now combining our answers, we are going to get the integral of f of x dx will simply be equal to ln of x minus 1 plus c1 plus half, now here I'm here, plus half the ln of the absolute value of x squared plus 1 plus c1 plus c2. Now adding a constant and another constant will give us a constant, so our final answer will be the integral of f of x dx will be equal to the ln of the absolute value of x minus 1 plus actually you can write it as ln of the square root of the absolute value of x squared plus 1 plus k. Now I like using the constant k because it is the letter that begins with my name. So that's our final answer. There. Now question 4 sub 2 says, by using the substitution u equal to sine x, find the integral of cos x divided by 1 plus sine squared x dx. The question here has already simplified our work by giving us the substitution. In other cases you won't be given the substitution, so you are the one to figure it out, but since they have given us the substitution, we simply use it. So we have u to be equal to sine x. This simply means that du will be equal to differentiating sine x, we're going to get cos x. Now we're differentiating with respect to x, so du will be equal to cos x dx. Now let's go back to our function. The function is cos x dx divided by 1 plus sine squared x. Now notice that du is the same as cos x dx, so this is what you'll be looking for, this kind of questions, to always make sure you can equate something to something simpler. So we know that anywhere we see cos x dx, we are going to replace it with du, so this will be the same as the integral of du, now divided by 1 plus, now here we said u was sine x, therefore u squared will simply be sine squared x, so we know that u squared here will simply be sine squared x. So we'll come and substitute here, we are going to get u squared. So now this is the same as the integral of 1 divided by 1 plus u squared dx. So as I said, du by differentiating with respect to u. Now as I said earlier, I'm going to make a special video on integral. Here is a special form of integral. The answer here is simply the tan inverse of u, but our u was sine x, so our answer will be tan inverse of sine x plus k. So that is the answer for sub 2. Question 4 sub 3, we are going to get the question say find the integral of x plus 2 and e to the 3x dx. So there is an acronym which is called LIET, normally represented like this: LIET, which L here is a logarithmic function, x is log function, I is inverse function, A is algebraic function, E is exponential function, and the T here is trigonometric function, T here is trig functions. Now the order in which this acronym is written simply gives us the way in which we are going to use our substitution U. We know we are going to normally integrate this by part, right? But to do integration by part, you need to let a substitution U to be equal to a certain term in the integral, just as it was given in sub 2 here. Our U was already given to us, but this time around I don't want to look for our U. But what will guide you to look for that particular unique U, that is the correct U, will be this acronym, which is very important even in further mathematics. Now we have log function. Is there any log function? No. Is there any inverse function? No. Is there any algebraic function? Yes. This is an algebraic function. Now this is an exponential function. Whenever two of these means, we will normally take this because it comes first. So our U simply be x plus 2. So what does this imply? That du will be equal to dx. Once you let your U to be this, then you need to let dv to be the other function. So our dv will simply be e to the 3x dx. So that we take the integral of dv, we just take the integral. So these are the steps. As I said earlier, I'm going to make a special video for integration in which I'll take you guys through all the steps of integration. Please subscribe to my channel so that you'll be notified. Now the integral of dv will simply give us v to be equal to, now the integral of e to the 3x. One thing I use with calculus is that once you're integrating, you divide. Once you're differentiating, you multiply. That is just a simple thing I'm going to say for this part. So this is the exponential power, and normally we let u to be 3x, and the steps are so many I cannot do in this video. That's why a special video will be made for calculus, differentiation, integration. There are so many things in it, but I hope I'm going to take care of it. So differentiating 3x, we're going to get 3. As I said earlier, integral with divide, so this will simply be 1 on 3, and we'll copy the same function, 3x. Now after having this, we know that our formula by part is the integral of u dv will simply be uv minus the integral of v du. So we are going to apply this formula. If you apply this formula, we know that our u was x plus 1, right? So this will be the integral of x plus 2. I think it was x plus 2. Now our dv was e to the 3x dx, so e to the 3x dx. So what do we notice? That this is our original function. This is it. So our u here now is x plus 2, and our v is 1/3 e to the 3x. Now if boundaries were given, we're simply going to write the boundaries here, the first value x1 and the second value. But since boundaries were not given, we're simply going to allow it like that. Now minus, we have the integral of v. What is our v? 1/3 e to the 3x, e to the 3x. So if we simplify our answer, we're going to have here, this will simply be 1/3 x plus 2 e to the 3x, now minus 1/3, we can bring the constant out, the integral of e to the 3x. So if you remember, we had something similar up here, so we're simply going to get the same answer. So this will be 1/3 in bracket x plus 2 e to the 3x minus 1/3. Now differentiating here will get 3, so we divide, so times 1/3 e to the 3x, now plus k. That's our answer.